Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, Move Fast to the 5G Converged Core, sponsored by Mavenir. Our speakers today are Dejan Leskaroski, Head of Product Management at Mavenir, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch our debaters discuss a topic live on video. We like to encourage our audience to participate in the conversation. Please share your comments and questions using the Q&A button at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed. So please do not hold your questions until the end. And a quick tip to our audience, as tempting as it might be, please do not share comments using the chat function because our speakers don't monitor the chat during the webinar, but feel free to share your comments using the Q&A button instead. And with that, I'll hand it over to Monica.
Kendra, thanks so much for the introduction, and Jan, thanks for being with us today. This is a somewhat special Sparring Partners because we're going to be discussing the results from a paper, and you have the opportunity to ask us questions about it. But at the same time, we're going to go deeper and wider than the paper, so the paper is not required reading, but it's useful. And we don't want to duplicate what's in the paper already, but we want to give you some color and some background in what happened behind the scenes. And so with that, what we're going to talk about today is the 5G core. And we're going to try to answer questions such as, when is it a good time to move, if you're an operator, if you have a 5G network, when is a good time to move from non-standalone to the standalone core? And should you move to the standalone core anyway? What are the benefits? What are the costs involved in that? And so Dejan Leskaroski at Mavenir has been working with me. We're working together on this model. So let's get started with Dejan introducing himself, and then we will go and as Kendra said, please do answer your questions as we go along. We don't have a Q&A at the end. We will take questions as they come in. So Dejan, welcome, and please tell us who you are and what you do at Mavenir.
Yes, thank you, Monica, and good morning or good afternoon to everyone joining. I see a good participation list. As Monica said, my name is Dejan Leskaroski. I lead product management here at Mavenir for our Packet Core business unit, under which umbrella it's a portfolio of approximately 20 cloud-native functions, which are supporting our 5G core standalone solution, as well as our converged packet core, which includes support also for 4G, 2G, 3G, and Wi-Fi access as well. So a pretty wide portfolio of complete Mavenir home-built cloud-native portfolio as part of Packet Core.
Yes, so before we get into talking about the core, I wanted to ask you a question on behalf of the audience. Whenever I hear Mavenir, it's usually in association with Open RAN. And we're not talking about Open RAN today. Well, we might, but that's not the main topic. So can you tell us, is Mavenir doing anything else other than Open RAN?
Of course, yeah. I mean, of course, Open RAN has been quite a bit in the news, and for the right reason. Mavenir has been kind of spearheading and leading the Open RAN movement. So there's been a lot of discussion, and of course, Mavenir has been part of that. And there has been some previous papers done in terms of TCO analysis with Senza around the TCO savings on the Open RAN side. But Mavenir, it's a complete portfolio. It's all software end to end. You know, obviously starting from the access side. Of course, we'll talk about Packet Core today. But in addition to that, our IMS, our voice services, messaging services, Mavenir has the largest deployments when it comes to virtualized voice services and messaging services. We also have private network emerging business, which combines both the Packet Core and the Open RAN. analytics portfolio. But of course, today we'll focus on the packet core piece. And again, even within the packet core, as I was mentioning, there's quite a bit of large number of network functions that both are designed to support the 5G SA, but also have combo functionality to provide 4G and 2G and 3G support. So quite a bit of investment, again, across end-to-end portfolio to make sure that operators can deploy the full network.
Excellent. Okay, so I was trying to actually send out a link to the paper, which I'm gonna do right now. I think it didn't go to everybody. So let me do this. So there is a link so that you can download the paper on the TCO. And so good. So we're gonna talk about the core, and eventually we'll get back and see how that relates to the RAN. But maybe we can get a little bit get started about the TCO, why we did the TCO and what we're finding out. And every time you do a model, you actually find out things that you were not expecting, and this was no exception. So we found a lot of things as we were going along. And I'm going to talk, maybe what we can do is that I'm going to give a summary of the results. But before we do it, Dejan, can you tell why did we wanted to do it? What questions we were trying to address? Because this is a new thing. So people want to know what the TCO is, but can you tell us a little bit about, give us a little bit of the background for this?
Yeah, and I mean, this question has come up obviously with many of our customers, operators, speaking to, when do I actually make the move to 5G SA? Of course, a lot of the operators today, they have invested in their 4G technology. And then there is a step there that, kind of continue with the existing investment and maybe go to 5G NSA, which we'll talk about the pros and cons and kind of continue to invest in existing technology, or basically saying, when is the right time to move to a 5G SA architecture? I think sometimes when we kind of get into the discussion, right away, operators or just in general, the industry kind of tends to gravitate to 5G only use cases. But it's not just about the consumer market, and we'll expand a little bit later. But the whole idea here was to say, look, there's no need to continue and wait to make the kind of the investment and go into the 5G SA architecture. It does bring a lot of benefits. Longer do you wait, you cannot reap some of the both CapEx and OpEx benefits that a 5G SA or 5G converged core can bring to the operator. So it's really more about when is the right time for an operator to make that switch. And in a paper, we kind of provide a breakdown of the different years, depending how long you wait, in terms of how much savings you can actually achieve by switching to directly to a 5G SA core.
Yes, and so we assumed that you want to move to SA. It's not, you don't have to, but clearly that makes sense. It's a way to use the full functionality of 5G. So we made that assumption, and so we as Dejan said, we look at, does it make sense to move sooner rather than later? And clearly, change is expensive always. So if you move to SA, to the converged core, right away, you have an upfront cost. So if you postpone it, you can postpone the upfront cost of moving. So the question is, what does it look like in terms of OpEx and CapEx combined if you postpone the move or if you don't? So Kendra, if we can have the first figure, that would be great. So this is a little bit of a departure from the rules. We do have a few figures today. So here are the sort of the main results. So what we assume, you have two different cases. We have the late adopter and the early adopter. The early adopter, so this is an operator, think of an operator that has a 5G network. And it has a choice to move to SA on year one, or to do NSA at the beginning, and then on year 4 it moves to NSA. And so in this case, what we have seen is that there's a 27% reduction in the overall TCO, so CapEx plus OpEx, for the early adopter, And for the capex, the total the capex savings is 32%, and this is because you don't have to have the operator doesn't have the SA the NSA plus the SA capex is only the SA, and then we have a 39% savings in the yearly OPEX because you don't need to run 2 cores. Basically, you just need to have one. And so this is the basic result that we got. And then we're going to talk a little bit more about the sort of further learning on this. But Dejan, can you tell us what are your thoughts on this? What is was this something surprising, or what was your take on this? And Kendra, we can go back to our video.
No problem. Yeah, so I mean, we expected obviously on both on the capex side and the opex sides to see savings. Of course, we work with models to make sure that what type of savings we can quantify. I'll start with the operational side first. Obviously, one big advantage from an OPEX perspective is moving to a converged core that can support your 5G subscribers, but also can support your 4G subscribers as well. So, you move to a single converged core. As you said, Monica, you minimize the need to run multiple cores. So that's one, obviously big aspect of the operational savings. The other piece is that when we talk about 5G, it's not just about kind of going to another packet core that enables a new access technology. There is a big part of the transition to 5G in terms of moving to cloud native, moving to CI/CD implementation, automation. So the way operators are managing their networks, the way operators are deploying new software, the way they're testing. So there's another aspect of overall OPEX savings when it comes to having a core that, again, it's not just about the 5G or the converged part, but also taking advantage of automation, CI/CD, and just overall, deployment model. So that's one thing. On the capex side, same thing. Operators at some point will make that investment into a 5G SA core. Again, being able to support, have a user plane function that can support both 4G and 5G reduces the per subscriber or per byte cost. So we expected both OPEX savings as well as CAPEX savings because, again, you're converging to a single core that can leverage both 4G, 5G NSA, and 5G SA.
Yes, and one thing that I would like to mention, and this was really a collaboration between Mavenir and Senza Fili, because it's a challenge to find out what are the real costs, especially if you look at 5 years from now, because this is a case where you don't have historical data. So we know how much, what's the cost of putting a new cell site because we have decades of experience in that. Here, this is all new ground. And so, Dejan, can you tell us how did we go about finding out what is the best estimate? Because clearly it's in the future, so it's an estimate. How did we go about it?
Yeah, so there were 2 parts of it, right? One was purely from, software cost, licensing cost, what is the cost per subscriber? What is the cost per example, gigabyte? We made assumption in terms of calculating the overall CAPEX. And again, one big improvement and where the CAPEX savings are shown is that you're paying the same amount per byte, either for a 5G, 4G, or 5G NSA subscriber. So whereas maybe if you have, for example, running 2 cores, you are, for example, paying for an EPC and the throughput on the EPC, you're paying some additional surcharge or upcharge to software upgrade to 5G NSA, and then eventually you're going to have to pay the same amount of money for 5G SA. So that was one part of the assumptions we made in terms of how do you calculate the overall CAPEX. On the OPEX side, I mean, everything from how long it takes to deploy a 5G core versus legacy, making the assumptions that we are cloud native, the process of how long it takes to, for example, deploy all the network functions has significantly reduced. Being able to manage, again, if you just take the simple math of having 2 packet cores, one on 4G, one on 5G, having to collect, different type of KPIs, different type of faults, alarms. That, right there in operational aspect takes 2x the effort. Where if you move to a converged core, you can actually reap the benefits of having this. So again, CapEx was more about per session and per throughput savings. On the OpEx side was about the simplified operation as well as the simplified management of a cloud native core.
Yes, and so the model was we did the model on assuming a network, a 5G network that had about 10 million subscribers, and then also IoT devices that go up to I think 5 million in year 5. So we used both human monitored devices and IoT devices. But one thing that we did not do was to look at the benefits of a standalone. And this is because we wanted to keep it simple, and we wanted to make a good case that just by looking at the cost, there is enough of a reason to move to standalone. And then the benefits are on top. So you're not going to complain if you get more savings rather than less, but those are more difficult to quantify. And also, I think we need to keep in mind that, this is basically a cost, right? You need to move to something else. And so the question, and some people are asking, do you really need to move to SA when it's a cost? And I think that the issue is that, no, you don't really technically need to do that, but you want to do it because that's a way to use the full functionality of 5G. One way I like to think about it is like if you buy a Tesla, it's a very expensive car, and you can use it as a regular car, but that kind of misses the point. So you can build your 5G network with all the sort of capabilities, but then unless you have a say, you're not going to be able to use them. So what's the point? So you're kind of not really getting all the value from your investment. Clearly, if you're buying a Tesla just to impress your friends, then you're fine. You don't need to use any of the capabilities. But then again, is that the best way to spend your money? So, so what we didn't look, again, we look at the cost, so TCO, so CapEx and OpEx, not the benefits. So Dejan, tell us, however, what are the benefits? Because, you're doing the same, so what is it good for?
Yes, no, and, just to kind of touch on a couple, that's very important points. So yes, we purposely created build this paper to kind of zero down on the kind of the apple to apple compare, right? So CapEx and OpEx. But the one big thing that definitely adds the value is over the top benefits that a 5G SA core brings. So, even going back, for example, one reason why an operator may want to switch to a 4G or 5G NSA core to SA is obviously the CapEx and OpEx savings. The other thing is, what are the other things that 5G SA brings to operators? So with 5G, it's not just about, for example, the consumer use case. So a lot of times you can say, hey, I have 5G access, I have 5G, eNode Bs and gNode Bs deployed. I have, I can, cover my subscribers and that's it. With SA, so things that come, as benefits. First of all, there's a true separation of user plane and control plane. There is discussion, obviously, in CUPS in the 4G world, but where now you can actually take the user plane function, the UPF, bring it closer to the edge, do local data breakout. So now you can take advantages, for example, of MEC use cases, edge computing, really bringing the user plane very, very close to the edge side and co-locating it with your RAN. So that's one thing. Network slicing. So being able to actually leverage a core where maybe in the past operators had either have to use the same core or even deploy multiple cores for, let's say, IoT use cases, enterprise use cases, consumer use cases. Being able to leverage a lot of the parts, let's say, for example, like subscriber management, like policy management as common, and then actually deploy network slices when you have dedicated, session management and user plane for IoT, for enterprise, and then of course for consumer. And then the third benefit is Now moving to a cloud native architecture, being able to deploy packet core in different clouds. So traditionally, most operators have deployed things on their own on-prem private clouds. But by moving to containers, by moving to a cloud native architecture, now you kind of open the door that you can have public cloud deployments, you can have hybrid cloud deployments. So that adds another benefit where you can have pay-as-you-go models. You really, again, opens the opportunity for operators to say, look, it's not just about one core, it's just about one consumer use case, but it's really now I can go after enterprise use cases, I can go after edge use cases, massive IoT use cases. So it just opens the door for a much bigger variety of use cases than just the consumer model.
Yes, and I think that back to the, as I said, it's not just a consumer, it's enterprise, and it's really a new way to think about the network management. So slicing is not just about some application that need network slicing. It's about thinking of the network as a resource and what's the best way to manage it. And that's where you really need to go end to end. And I just put a link up on an article that just came out yesterday on exactly this topic. So we really need to think about, when you think about the benefits, it's more than just the core, the traditional core functionality. It opens up many new venues. Well, we have a few questions that I think that are for you, Dejan. So the first one is, how is the CI/CD contributing into your TCO savings?
Yeah, so the biggest thing here, and we've actually done it with few tier one customers, both in North America and Europe, is how quickly can you actually deliver software to customers? How quickly can be tested? Of course, automation is applied, and how quickly you can deploy things. So, typically in the traditional way used to be, you had a long roadmap cycle, maintenance window planning. It can take 6, 9, 12 months to roll out new software, to deploy something new. It was very, very vendor specific. So if I'm an operator, one vendor may be doing it one way, the other operator may be doing it another way. You may have multiple labs where you're soaking or testing your new software loads. So all that takes time, which costs money, resources, which of course cost money, and then people, right? So with CI/CD, it's first of all, and we've seen operators do this, they are standardizing on one way of delivering software across vendors. So, I keep saying cloud native, but with cloud native, there's a lot of other things that Mavenir has adopted, and of course, operators are pushing other vendors to adopt in terms of how you deliver your software, your images, integrating with things like Harbor, like GitLab or GitHub. So from one way, CI/CD really simplifies how vendors will actually deliver the software to our customers and operators. And then on top of that, it's really about using the same test framework. So the way we test our network functions with the way we test new software, we can apply the same automation and same test techniques to the operator. So it's really almost like a very, very close handshake where as soon as software comes out of Mavenir's test cycle, we can actually provide it to our customers. One example, unfortunately, we can't mention the name, but it's a tier one operator in Europe. We were able to actually provide weekly software updates. They're launching their 5G SA product, and they had some very, very stringent timelines. So it took us about 20 minutes to deploy an end-to-end packet core. And then as new updates were coming in, we were able to actually deliver and upgrade the packet core, the 5G core, within minutes. So those are kind of things that in the past, operators could not take advantage. It was a much, much broader maintenance window where CI/CD can really take advantage of that.
Yes, and I have to say that in the model we made some assumptions about the cost savings, the OpEx savings from CI/CD automation and all that. But in reality, so we look at a sort of like a static picture in the model because that's what the models do. But in reality, you can expect those savings to cost to increase cost savings to increase over time because you get better at using it. So I would imagine that, your operator, might say, okay, now we have weekly updates. Eventually it could be a daily update and there would be no problem. It would just be the standard state of affairs. It's something that it's improving as we go along.
And Monica, I saw a follow-up question which is related. So just kind of want to touch on that as well. It looks like CI/CD tools. I think this is also a very important and good question. The other aspect of CI/CD, it's actually to use open source tools. Again, I think the Cloud Native Foundation has done a lot for telco, and this should be a best practice moving forward for many vendors where vendors should be using open source tools as much as possible when it comes to content as a service, platform as a service, as well as CI/CD. Sometimes telco has a bad habit of kind of going down the proprietary route, but as you can tell from Mavenir standpoint, both on the Open Range side as well as the packet core, the whole idea is first of all, pick the best of breed in different functions, and two, if there are tools out there, and especially in CI/CD, I mean, CI/CD is not a new concept. It's been used in other industries for a long, long time. And things like GitHub and Harbor and Traffic and all these different tools are open source tools that have been developed and used for many, many years in other industries. So absolutely open source tools. One thing I will say is we have seen two different models where an operator can come to Mavenir and say, hey, they have already picked their CI/CD pipeline, so we integrate with their CI/CD pipeline. And then we have operators where, and again, this could depend on the size of the operator or just how their organization is structured, that says, look, I need Mavenir to bring your own CI/CD pipeline and integrate within my network. So we've done both. But the key undertake based on this question is that, yes, definitely open source tools are used as part of our integration.
Okay, since you mentioned open source, let's talk about openness in general, because clearly, so there is a commitment that you have to create an open ecosystem. And I think that's where the part of your work, your work on Open RAN and the core sort of merges, because again, it's not, you need to open the RAN, you need to open the core, but then there is even a bigger value by having both of them open. So because if you open only one thing, but then everything else is closed, that's just quite as good. So maybe you can talk about the synergies of the overall approach to openness and how does the two parts fit together? If it's it's not even two parts in a way, so it's the same. But anyway, if you could talk.
No, it is, and I think when it comes to openness, it's kind of both ways. One is kind of I'll say horizontal openness, meaning operators should be able to choose best of breed, starting from the access side all the way to the packet core side, right? So now it doesn't necessarily. It can be one vendor, but that should not be the default, right? So we recently published a paper and can be found on our website in terms of service-based architecture and what service-based architecture brings, where a customer can kind of pick best of breed when it comes to different, again, Open RAN components, and especially if you look at packet core, there's over 20 network functions. Yes, there are some of the big vendors that are developing all the functions, and there are use cases where picking one vendor like private networks may make sense. But if you're building a large network, you should be able to select, best of breed user plane, best of breed policy, best of breed subscriber management. In the paper that I'm referring to, it's a Mavenir written where we kind of compare it almost like a golfer. You should be able to use golf clubs from one vendor and golf balls from somebody else and shoes and dress. So in telco, we kind of said, look, it's one vendor or nothing. So again, keeping it open interfaces, easy to integrate. I think that's the other thing with 5G SA and moving to a service-based architecture. We've done this, with multiple customers where we have integrated with other third-party network function, something that used to take 3-6 months. We've done it within weeks, and it's based on just having open HTTP-based, REST-based service interfaces, where before used to be these very heavy 3GPP protocols like Diameter and others that took forever just to integrate two different functions. So that's one thing on the kind of the across network function openness, but then also up and down the stack. So the idea is that when people say application agnostic, it really what that means is I should be able to run on any platform, being on a private cloud or being on a private cloud. I should be able to take something and run on AWS or Google. I should be able to run it on vanilla Kubernetes, on VMware, on Red Hat. So again, that's the other openness when a vendor provides a software to say, look, you don't have to buy the whole stack from us. We can integrate southbound, so open Casa and PaaS, and northbound. You may have your own service assurance tools. You may have your own network slicing tools. It's really about an open ecosystem that Mavenir is trying to bring.
Now, there is a discussion going on this, and that is how much openness is good enough. Could you have something like too much openness? And so the question is that just because you can have as many vendors as you want to, do you just want to have the max or not? I mean, so can you tell us what's your view? Because I think that, openness is a great value, even if you don't use it on day one, so to say. It is the potential for it. And that's where I finally convinced myself that Open RAN is actually great for enterprise private networks, even though you have a small network. And on day one, you might just have one vendor because you have a very limited deployment. But the fact that anytime you can change it, it's a huge value, even if you don't use the openness right away. I mean, the openness, like the multi-vendor system, is the fact that the multi-vendor system exists out there as an opportunity. But can you comment on it? Could you have too much openness? Where do you draw the line? Or is there a line?
So the way I look at it is that it's really, just because everything is open, that doesn't mean that operator has to have 50 vendors in their network, right? It's really all about the options. So openness means, depending on, again, the use case, the operator. There are some operators out there that says, you know what, I need something very small, very controlled. I don't have a big operational teams. So in some of those cases, maybe a one vendor or two vendor make more sense. But that does not mean that you're not given the option to choose later to change. So, openness, it's really up to the use case. But just, for example, things like, let's say, I mentioned subscriber management. So typically subscriber management, especially if you have a network that is already deployed, you may not want to move subscriber management to another vendor, right? But that doesn't mean that you should continue with the other functions like user plane, especially with the new 5G core functions to stick with the same vendor. So again, it's really up to the operator, really up to the use case. We have things like, for example, operators deploying fixed wireless access to say, you know what, I'm going to go with a end-to-end solution. There's about 10, what we call a minimum viable set products from Packet Core. And they say, look, but tomorrow, if I want to change, and this comes very often. So fixed wireless access, as I'm mentioning, we've seen operators say, look, I'm going to go with one vendor, but tomorrow, especially when it comes to user plane, when I start thinking about edge applications, when I start thinking about IoT applications, I may decide tomorrow to bring 5, 6, 10 different user plane functions, because you never know. I mean, we're talking here 3, 4, 5 years in the future. There may be niche vendors that are developing edge applications and user plane functions. So you should pick something today that doesn't kind of prevent you in the future to have an open architecture.
Absolutely, and so clearly that's it's the option. Now there is also another argument about yes, you want to be open, but if you inject some proprietary elements, then you get better performance. Or the other way, that's so. How do you address that?
So on our side, again, we've done this kind of a full shift to containers. So we don't rely on any proprietary. Of course, we don't rely on any proprietary hardware or any proprietary software. So things like, for example, DPDK, VPP that are integrated to accelerate the user plane. Those are, again, open source, components, Intel developed, and others in the community. Now, there are use cases where, for example, you can say you can have better performance if you do SmartNIC offload or take advantage of some hardware acceleration techniques. But even those are not vendor specific. There are SmartNICs by NVIDIA, by Intel, and others. So there could be hardware that is more suited for better performance. But at the end of the day, that's not, for example, Mavenir specific hardware or a software vendor specific hardware. Those, again, they're open ecosystem where a customer can say, look, I have a COTS hardware from Dell or HP. I have this kind of NIC cards. And yes, I want to take advantage of SmartNIC offload. But again, it's not a vendor specific requirement. It's really more, again, about the open ecosystem. So that's how I look at relying or maybe leveraging some kind of hardware acceleration in the future.
Yes. Now let's go to some of the questions. So there is one that I'm going to take, which is very quick. It's Greenfield or brownfield. In the model, we look at brownfield simply because we wanted to make the change, the comparison between, well, we assume that the operator had a 4G network, only because of that. And also there is a question of, we have a fiber core. We're looking to combine fiber with 5G and IoT. What's the best path?
Yeah, I can take that. I'm assuming by, if I'm understanding the question correct, this is probably around wireline access. I'll answer the question that way, but if I'm misunderstanding, just let me know. So this is the other thing that actually 5G and 5G SA brings differently. So it's basically wireline and wireless convergence, whereas this was not possible before. Now you have the WAGF, which is defined as part of the 5G core framework. The WAGF can be integrated with a 5G core AMF and 5G core UPF. In fact, we are working with some of our partners in that area, where now you have a seamless convergence between wireline and wireless. So on one side, if you're looking purely at a 5G play, and this is, again, both on the network functions, as well as there are some features like ATSS, it's a mouthful, defined by 3GPP, where it's specifically designed to have a convergence between 5G wireless and 5G wireline. If you have an existing network like BNG and some of these other components that are 4G, even within that 3GPP specification allows you to actually integrate your existing wireline network functions with a 5G core. So very good question. In fact, that's something that we have seen operators ask for. I think it's the next phase. In fact, even when I said I mentioned 2G, 3G, 4G, 5G, and Wi-Fi, I failed to mention wireline. But I think that's the next evolution where operators will converge, just like we talked about convergence of 5G and backwards compatibility to 4G. It's convergence between wireline and wireless.
Absolutely. So there is another question from Etienne about how the MNOs are reacting when you propose weekly upgrades, and the telcos don't usually like changes in their network. And I want to say something because I just had that conversation very recently with an operator, and they exactly said that. But then when you talk to them, you realize that the reason why a software upgrade is an absolute nightmare if it happens very rarely, and it's a big one. And that really requires a whole lot of effort. So I think that, and this is, you think about upgrades for anything. If you have frequent updates, the update is clearly going to be more restricted in scope. So you just learn to do it, and it's going to be less of a traumatic experience. And so I think that the question is that, yes, if you have to do the big software upgrades every week, it's going to be deadly. But that's not what we're talking about. Right. Yeah. I mean, that's
correct. And again, I agree with the statement. Telco doesn't like changes. And so let me kind of touch on a few different points on this. Right. So very similar to the open architecture, the optionality is there. So now it's just because we have open architecture, operator doesn't have to have multiple vendors. Right. Same thing here. CI/CD and being able to deliver software updates at a much faster rate. It's an option. We do have operators that say, look, I have a particular use case like fixed wireless access, maybe satellite, maybe like a tier 2, tier 3 market that, look, I deployed it. My customers are happy. If it's not broken, don't fix it. Let me know, in 6 months or 9 months when you have your cadence, and we'll do the upgrade. So that's still there. We're not taking this away. What we're talking about is being able to provide quicker updates. Now, Monica is making a really good point. It's not necessarily a lift and shift every week. In other words, if you have built your packet core the right way and you've done a microservice architecture, you can actually, I'm taking an AMF as an example, which can be, it's kind of the translation of MM. It's a fairly complex functionality. It has to talk to your access network, everything. You can actually upgrade a particular microservice and only that microservice. So when we talk about CI/CD and delivery, yes, you can deliver a full-blown major release. And those, of course, that doesn't have to happen on a weekly basis, but you have the optionality that you can actually take and upgrade a part of your network, even within a network function, a particular microservice, so you can actually take the benefits. One of the big things for customers, and again, I'm referring to one customer, but this applies to others. This particular customer has 6 months to launch their 5G network, and they're testing different phones. So when we provide a new software update, it's particular part, either a network function or particular microservice that was upgraded. So these frequent updates were very isolated in a network. And again, I think it's a paradigm shift. It'll take some time with telco, but you look at the industries, like Netflix and Hulu and some of these things. They make constant updates to the network. I'm not saying telco will maybe get all the way up to there, but we have seen customers take on CI/CD. They've been much more open to actually be able to take software on a more frequent basis because they know it's only part of the network. It's not a big upgrade every single week.
Yes, and so I think it's again, it's a different approach. So it's more than the standard core. I mean, the standalone core. It ushers it gives the opportunity to make bigger changes. Now you mentioned fixed wireless access before. And so you could imagine that an operator has this FWA network. Do they really need a say?
So it's interesting. One of the biggest uptake in 5G SA has been around fixed wireless access, believe it or not. I mean, both, again, actually APEC, Europe, United States, it has been a use case because the way operators are looking, and this is kind of going back what I mentioned earlier, consumer, of course, there was a big wave of deploying 5G, and many operators deployed 5G and SA to kind of address the consumer needs from that aspect. But now even operators, they have kind of decided to go with a certain path or vendor on the 5G consumer side. We now see deploying separate packet core just for fixed wireless access. It actually opens, and again, another use case for these operators. And this could be your traditional CSPs, can be cable operators, can be Greenfield operators. They're something that they may have done in the past using 4G. They're moving to 5G. So 5G SA fixed wireless access has been one of the most dominant use cases that we have seen with operators. So absolutely, I think of course other use cases are coming, but that's probably the most common use case we've seen with customers, and in every case has been 5G SA. Now, when I say 5G SA, that does not mean that they can only do 5G fixed wireless access. With the Mavenir packet core, because it has combo functionality, they can still do 4G fixed wireless access, but they're using the same 5G SA core to do both 4G and 5G.
And I guess that if you have an operator that is deploying, it's a Greenfield operator, then you just want to go SA right away, right? I mean,
absolutely.
At that point, there is no need to go the other way around.
Absolutely.
Okay, we have another question from Frank Chen, and another one coming. Okay, so have you had experience integrating your software on different branded cards with limited or acceptable efforts based on the MNOs requests?
Yeah, so this has been another big improvement. Everything is evolution, right? So even when operators kind of started to virtualize their software, there was some of this decoupling. But now, at least, obviously speak from a Mavenir perspective, our software application has actually been decoupled several layers from the COTS hardware. So with very, very limited effort, running on, Dell type of servers, HP type of servers, Lenovo, IBM. So really being able to run on different COTS hardware has been greatly reduced in terms of how much time it requires to test and interrupt. In addition to that, so then you have the public cloud, the hyperscale providers, the AWS, the Google, Azure of the world. They have their own hardware. So same thing there. I'll use AWS as an example, but it's common for everyone else. Being able to run on AWS specific hardware, either in the public cloud or where they have AWS Outposts. So they basically roll out AWS hardware, and we can actually deploy on that hardware. So yes, the amount of time that has taken us now to validate or be able to run on COTS hardware has been very, very reduced. In fact, many times our sales teams can come in and it's always one off kind of a thing. And has been much easier to actually deploy a software on variety of COTS hardware.
Yeah, I guess, yeah, you got some experience there. We have another question here from the audience, from Dominic. So the cost of the 5G core as a percentage of the total 5G CapEx is higher for small MNOs than large ones, tier ones, but their benefits might be smaller. So do you still think that they should still move fast? Now, let me comment on the cost side, and then you can talk about the benefits. So on the cost side, it's pretty much, it's similar. So clearly the percentage might be higher, but the overall trend is the same, because you get, what we're looking in the TCO is the trade-off between initial CapEx expense, or a later one, and the CapEx savings. So it's the balance between the two. So the amount, say, per user might be different, per subscriber might be different, but the overall trend is pretty much the same. One thing that actually makes a difference is not so much the size, but is how many 5G subscribers you have. So let's say you have a 5G network and you only have, say, 1% of your subscribers on 5G, then the cost advantage is more limited, clearly, because it doesn't affect too many of your subscribers. So the more 5G subscribers you have, the sooner you want to move to SA. Which I think that this is something that we are already seeing. And the GSA just released some numbers, and they said that there are 99 operators that are already either have deployed or are investing in SA. So, but Dan, can you tell us what about the benefits? Are they different?
So they are, and just a couple points on that, right? So yes, I mean, of course, if you're a tier 2, tier 3 customer, your maybe 5G penetration or use cases may be different. Now, with that said, we've seen two trends with operators, with tier 2, tier 3 operators. One is because the 5G core is fully containerized, you can really shrink the amount of resources that are required to deploy a 5G core. So you can deploy a complete Mavenir 5G core in like 3 different servers. So from one aspect, even though 5G core has a lot of network functions, if you're again, using microservices, you assign fractional peak core. So you can really scale down, and we've done this with tier 2, tier 3 markets, where you can actually shrink wrap a full 5G core in 3 servers and provide it to a customer. Of course, there's software licensing costs, but from at least a resource perspective and deployment, you're still going to get a lot of CapEx savings. So that's one thing. The second thing, which is important, and again, this has been a big trend in North America with Mavenir, as some of these tier 2, tier 3 customers are replacing existing vendors, Chinese vendors, in specific. What we have taken a model is the way that our 5G core is built is it's a combo core. So now what we have taken and deployed is deploy an SMF, which is a 5G function, and UPF, which is a 5G function. but they're actually acting or functioning as 4G nodes. So now you can still invest in a 5G core architecture, containerized cloud architecture, but your initial use case may only be 4G or 5G NSA. So we see a lot of tier-to-tier operators deploy a Mavenir 5G core, but initially using it for 4G, 5G NSA. Down the road, when they're ready to deploy 5G SA, they start adding the AMFs, the NRFs, the other functions. For example, like network slicing, they may not need network slicing from day one. They can add those components at a later stage. So yes, maybe the benefits are not the same for tier 1 versus tier 3, but believe it or not, a lot of tier 2, tier 3 operators, especially in North America, have taken the Mavenir core to kind of leapfrog. Some of even the tier 1s, they actually kind of start investing in a 5G architecture.
Yeah, and I guess in all this, I mean, we have to think that if you're a brownfield operator, you have all this large 3G, 4G network. So it's really important for an operator to be able to make sure that they manage their legacy network correctly. Is there anything that anything that operators should be aware or should prepare for in terms of managing legacy?
Yeah, I think so. One thing is, again, going to this kind of proprietary route. Every vendor has their own EMS, their own network manager, their own proprietary way of providing statistics and faults. And again, that's another way of kind of closing in on your operator option. I think one of the things is even on legacy products is to make sure that have open APIs. The way each vendor provides alarms to a NOC center or support center should be very standard. There's a lot of standards out there. They should be adapted. They should not be vendor specific. The way you provide logs, the way you provide statistics, things like Grafana, Kibana. Again, going back to this cloud native approach, there's so many tools that have been developed, telco specific and industry specific, that operators should be asking and pushing vendors to say, look, I need everything, even my legacy products, to have a common layer, a single layer for configuration, single layer for management, instead of having 5 or 6 different management console to manage 5 or 6 different products. And again, I'm not just talking packet core, right? We of course today packet core, but especially these tier 2, tier 3 operators, they have RAN networks, they have transport networks. It's more than just the packet core. So a tier 2, tier 3 operator cannot afford to have 5 or 6 different management systems. So it's really about centralizing on a common architecture, both southbound and northbound.
Yeah, and I guess that sort of it's interesting because you think of openness, multi-vendor, so it's more complexity, but at the same time, you also try to streamline because right now, because we already had. I mean, right now there is we have a lot of closed networks, but they're actually very complex and really multi-vendor, except that the vendors don't talk to each other. So multi-vendors, in a way, is nothing new, but you're trying to get the good part of the multi-vendor rather than the fact that you have this multiple solutions, which create a lot of duplication, right? I mean, because not everything is kind of on its own. So
silos, exactly. Yeah. The silo approach does not work. It has to have a common architecture, common observability, and I mean, again, I know telco will take some time to get there, but this is nothing new for other industries, right? Where if I was a web application developer, I can deploy my application on any public cloud, and I don't need to necessarily care about what's the hardware running underneath it.
Yeah. We have a question. I don't know whether I would prefer not to answer about specific announcements, but do you want to comment on the Casa Verizon announcement?
So I'm familiar with the announcement. I guess, I mean, obviously Casa has been in has some of those parts of the solution. Frankly, I don't probably have enough information of why exactly Verizon invested there. So I'll leave it there. I'm familiar a little bit with what they have done and what they're trying to do in terms of the private networks, but exactly why Verizon decided to do that, I don't know, frankly.
Yeah, I think that we need to have Verizon to comment on that. But I think it's what is interesting is that you start seeing more and more of different relationships being created, which I think is a good thing.
That is true. Yes, and that is true in general. I mean, I think, operators are working very, very close with vendors. I think that's actually a good thing. I mean, we talked about CI/CD. It's one thing. I think it's very common in the private and MEC networks where it's no longer just a vendor kind of throwing the software and letting the operator. So it's very, very much closer relationship when it comes to integrating the platform, integrating CI/CD, and kind of just touching on that, I guess, subject. When it comes to MEC and private networks, operators and vendors really have to work close together.
Yeah. Let me play devil's advocate here a little bit. And when we had, a few years ago, many years ago at this point, so there was virtualization came up as a possibility, and I was like, you have to virtualize right away, go. But then it really took much longer than expected, and I think it was a good thing because from an operator point of view, before you launch into something that it's a really massive change, you want to be careful as you go along. And so here, we talk, it's not just the core, it's a new approach. Is there a way in which you might have a similar situation where it might just take much longer simply because operators want to make sure everything it's safe? They're not going to get into out on a limb.
Yeah, no, I think, I mean, of course, with every new technology, there's always kind of, the evolution or the growing pains. I think what I've seen, I mean, it's making me sound old, but I have 20 years experience in telecom, and I know many others have longer, but you went kind of from proprietary hardware, then kind of the proprietary hardware got broken into ASIC. So, but that took like 3-4 years to kind of mature, and then virtualization came, and there were growing pains. I mean, there were growing pains with virtualization. Going back to the COTS hardware. I mean, I remember days that we had to make sure the NIC cards support the right plugins. OpenStack, in general, was not ready, and there is growing pains in containerization. But what I have seen is that the window of maturity has shrunk. So every new technology, it's almost like cutting the maturity time in half. So it took quite a bit to do one part. It did take some time to get VM and OpenStack and ESXi and some of these things be able to run on workloads. And the same thing happened with containers. Now, again, we're talking today with containers, but we've been talking to the likes of VMware and OpenShift and AWS for the last 3 years. So OpenShift, again, today it's telco ready, but this has been ongoing work with not just Mavenir, other vendors as well, but working with the platform providers to make sure that the maturity. So yes, to answer your question, it does take some time to mature, but every new kind of evolution, the learning curve and the amount of time it takes to get something mature, it's becoming much shorter. So I've seen this, like, to use one more example, hyperscalers, the likes of AWS, Google, and Azure. Initially we said, look, these are the telco is very finicky and very picky. This is what telco needs for web scalers. Within 6-9 months, we've seen a whole turnaround around the hyperscalers being ready to deploy telco workloads, being able to deploy commercial workloads. So yes, they're new things, but the way that the technology is maturing, it's much quicker than what happened in the virtualization space.
Yeah, and I guess also the other thing is that as you sort of decouple things in an open, so you can just move at different speeds in different directions, so to say. So you have a little bit more of a leeway in terms of where you want to go and exactly what to do when.
Yeah, and how do you develop the software? No, I'm gonna keep this short because we only have 1 minute. But the other thing is, see, Kubernetes is nothing new. Kubernetes is new for telco, but Kubernetes has been running workloads. So the whole idea is not to take software that was meant for proprietary hardware and try to run it over Kubernetes. Then you're always finding an uphill battle. The idea is to understand the cloud native architecture and build your application to take advantage of Kubernetes. If you take the other approach, it doesn't matter what Kubernetes does, doesn't matter what AWS does. If you have the software that is not meant to be cloud native, then you're going to have a problem. If you develop the software the right way, again, Kubernetes is not a new concept. for many applications. It's new maybe for telco, but if you build the right application, then you're gonna reap the benefits of that type of architecture.
On that, we're at the top of the hour. We could go on and talk about this for quite some more longer time. But Dejan, thank you so much for taking the time to talk to us. And Kendra, back to you.
Okay, great. Well, thank you to our speakers for that wonderful conversation. And thank you to our audience for the great comments and questions. That will conclude our webinar today. A recorded version will be available at senzafili.com in the coming days that you can access. And we have another Sparring Partners coming up on May 10th on Spectrum for the Enterprise, the Role of Regulation. Registration for that webinar will also be available on senzafili.com in the coming days. Thanks again, and we look forward to seeing you at future events.